2, 1, and we are live. All right, welcome everybody to this third class in Cloud Solutions and API Integrations. This is the third class is Cloud Storage and Databases. I'm the instructor, Jeremy Bergman, for Omaha Data Science Academy. Okay. All right. So how this class is structured, hour one, we'll delay the quiz a little bit. A few of you have taken it, but we'll let you do that in between breaks and the hours and cover it in hour three. And we'll go ahead and do an overview of cloud storage solutions with a focus on Azure Gen 2 storage, which is known in Azure as a data lake. In hour two, we'll start to introduce Azure cloud databases. So you've learned in SQL 1-on-1 class, or we call it the data management class, about relational databases. This will also include non-relational databases. We'll start to cover that and the different reasons why you would use those. And then we'll cover some Azure Data Lake tools. So a couple tools that we'll install today. We'll install Storage Explorer to be able to better explore all the files that you place into the data lake. And then we'll also take a look at Data Explorer for exploring the data that you also have in the data lake. So not just being able to place it there in these different solutions, whether it's a database or the data lake, but also being able to do something with it once the data's there, which will be a hands-on exercise today. All right, so objectives for tonight. So this picture over to the right is everything that we're going to cover tonight. So when I thought about lecture, that's why I said that I thought the lecture is going to be small. It'd be like a small one on databases and storage. It really ends up being a little bit bigger. So the top row, you have the different databases. So those top four over on the left side, I'll use my pointer here. Those are all relational databases that you can set up within Azure. Azure Cosmos DB is like all of the different non-relational databases. It has a couple of different databases and storage within it. So we're going to cover Cosmos DB tonight. Synapse Analytics, we'll cover that more, I think, in the next lecture. It's kind of a platform. It's like an all-inclusive platform for analytics. It has storage and processing, and you can do pipelines. You can do basically everything in it. It does have a MySQL scalable Azure SQL database, which is Microsoft SQL database within it. That's specially built for analytics. We won't cover it really here too much tonight, just bring it up, but we'll cover it more coming up. This second row is what we'll cover the most here in this first hour. So your basic storage is like your file stores, your basic storage, your blob storage, which is actually what Azure Data Lake Storage Gen 2 is. So a blob is like, you can store anything there. You store files of any type. It can be ones and zeros. It can be bytecode. It can be programming objects. It could be text files, regular data file, or it could be data files of any kind. Excel sheet. You can basically store anything that's a file. A queue is one for like messaging that's coming in. So if you have like streaming messages, you can put them in a queue and you can queue them up for processing. So like in order, like a queue, like a line of like transactions that happen or messages that are coming in. We'll learn more about that. Some of these technologies I've never actually used myself. I've never had a use case for a queue, but we'll learn more about it. Then we have a file share. So that's more like a network drive that you can set up in Azure to share files. Table storage we'll cover in a little more depth. Today I use table storage. It's a little bit different than relational database tables, and we'll see why that's the case. So basically it's the case because with relational table, you have to define the schema. It needs to be well-defined data. With the Azure tables, you can have a little bit less defined data. So you don't have to set up this database database table with this schema and keys and columns and everything. It's a lot more flexible type table that you can store information in. Think of it like an Excel sheet, maybe a little bit. And then managed disks. So we don't cover this too much here because managed disks are more for like virtual machines or applications, but potential that you'd come across it in data science. So we're going to end up covering all of this tonight with first cloud or overview of cloud solutions. So we'll go over a couple of different storage types. These are all different, I say types. So these are all different like types of ways that you can store data or files. And then on top of it, there are these different types of storage. So you can have hot versus cold storage. You can have private versus public storage. And then of course you can have Blob and all these others. So it can actually be a combination. You can have like, we'll see hot storage in Azure Data Lake, and then some of it you can actually define it to be cold storage also.
The Azure Data Storage and the Azure Data Storage, is that on the images at all? Like,
Hold on 1 second.
yeah, or my,
What's that?
the data lake tools on the bottom, are those on there? The pictures of images of?
They are not. They are
purposely, okay.
tools we're gonna install today, the data lake tools at the bottom.
Okay.
I'm just covering everything, all of the services that we're going to cover tonight, whether it's relational databases or non-relational or different types of file storage and ways to manage it. Tonight, we're also going to define what is a data lake. A data lake is specific to data. It's not really that much of a thing in programming, but it's blob storage, combination like a blob storage and file store that's or helps you organize like multiple sources of data. So think of like if you're in a big enterprise, you could literally have thousands of pieces of data, like from different systems or text files or logs or Excel sheets or services, API services, whatever it might be. Data Lake, it helps you organize those and puts them in a centralized location. So it helps you with management. And two, within Azure, it connects to all the different resources that we have, whether it's machine learning or data factory or something. It's highly integrated with the rest of them and optimized for that. So highly optimized for data. And that's kind of my introduction or sales pitch for Data Lake Gen 2 storage. So this is the Azure's version of it. You have it also in GCP and AWS, but we're focusing on Azure in this course. So in hour 2, we will focus on cloud databases. So non-relational is Cosmos database. We'll learn a little bit more of what non-relational means. It is a bunch of it's like different ways to store data that maybe for certain uses even more effective than storing it in a relational database. So we'll cover that and what that means. And then we have a lot of relational databases like you learned in the SQL 101 class. You have Microsoft SQL Server. In this class, we'll use MySQL. We'll use the same database that I use for teaching that class. But you also have Postgres and MariaDB. So Postgres is more of like people build applications often on top of it. It's an online transaction processing database. It's very lean, light, fast, very fast in transactions, and there's a lot you can do with it in SQL. MariaDB is the open source version of MySQL. Some people didn't really like it when Oracle took over MySQL, so they went rogue and made MariaDB. Then the data lake tools, we'll explore this at the end of the lecture and then get our hands on it in the third hour. Azure Data Storage tool, that's an application that we'll install to browse the data lake. And then Azure Data Explorer is a resource within Azure that we'll install to be able to explore the data that lives in the data lake. One of the ways that you can explore data that lives in the data lake. Okay. So we've talked about cloud already. So what is cloud storage? So cloud storage is a mode of computer data storage in which digital data is stored on servers in off-site locations. So not even necessarily, when you think of cloud storage, you think of a lot of these things on the internet, whether it's Azure or Box or Google Drive or something like that. You can connect to it on the internet. But it can just be in an off-site location where it's hosted for you by somebody else or a data center. So cloud storage is kind of all-encompassing, but in terms of how we're defining it, it's just any servers that are hosted or managed, or maybe usually managed by somebody else would be cloud storage. All right, so that comes to a second point. They're maintained by a third-party provider who's responsible for hosting, managing, backing up, and securing data stored on its infrastructure. The real benefit or advantage of that is that what's twofold is that you don't have to worry about it yourself. And oftentimes it's good in business because it actually, that third-party provider is like responsible for keeping your data secure. So you usually have a contract with them. They worry about the security and you don't have to worry about that as a business. Right, so today, you usually think of cloud services. These are like individual cloud services, and we call this part of the public cloud because many people have access to it. It'd be Google Drive, Box, Dropbox, and Box. But of course, now that we have these platforms like Azure, GCP, AWS that provide enterprise storage solutions for big companies, their applications, their big file storage, their data. Like something that you wouldn't want to do all in Dropbox or something like that. So it's like a platform as a service is what we called it, or a big solution for enterprises to be able to multi-stack solution for companies and ecosystem be able to manage their applications and their data. So the advantages, it's kind of some of the advantages we've already seen. But I kind of like this one because it positioned it a little bit differently and related it to data a little bit more. Is that you save space. You don't have to do so much. Don't have to have so many drives. Maintenance cost. Of course, you don't have to manage your own hardware potentially. No technical knowledge. That's probably not. You probably need a little bit of technical knowledge, but you don't have to know the nuts and bolts of like different types of hard drives or memory or networking and stuff like that, or have a team of people. Enhanced security in general, you actually probably get a little bit better security out of these cloud platforms because it's their focus. If you were to do it yourself, maybe there's something that you'd miss out on, or there'd be a hole in your network. Multi-device access is one of the advantages of cloud, especially in data. It's about collaboration, and you can have multiple devices or people accessing data that's in a centralized location or dashboards or reports. Scalable, prevents data corruption. So usually the third party is responsible for that also. And then in general, it's usually pretty easy upload and download. Even into the data lake, you can use a utility to be able to do it, or Box or Google Drive, you can just drop the file into your browser and it will download itself. So it's potentially easy to use. Kind of saves space in a way because I found like you can have files just all over the place on a network. and it's like different versions of the same file. At least it all centralizes it into one place. So you could potentially save some space there too. All right, so that's cloud storage. I think we'll dig a little bit deeper into the more benefits of it coming soon. We'll start to talk about public and private cloud, which is where we start to talk more about third-party providers and stuff like that. So this is really just an overview of what is cloud storage and the benefits. Okay. All right. So cloud storage terminology, just like anything technical, just like to put the jargon out there or some of the key terms or things that you want to know. So there's public and private cloud. We've covered that a little bit, but a little deeper, more well-defined definition of public cloud is a cloud service offered to multiple customers via the internet. So it's a third party that's doing it, who's providing it to multiple people. So Azure and those cloud platforms would be considered public cloud. Box would be considered public cloud also because they have millions of users on their platform. Now a private cloud, I've also seen this before in my experience. So cloud environment dedicated solely to one organization. Private clouds can be hosted on-premise or by third-party service providers. So these are hosted by somebody else. It can be like on-premise, on your premise. It's usually managed by someone else, or a third-party per service provider. So in IT, there's a thing called managed service providers. So if you're like a smaller business or you don't have these people within there, you can hire a managed service provider to manage certain parts of your IT. So I worked with one in healthcare who focused specifically on HIPAA compliance and security and hosting, management systems. They had like a very, very specific focus, and they set up a private cloud for us. So they set it up themselves as a third-party vendor and only allowed us to access it. There are advantages to that. It's a lot more secure. There's a lot more customization you could do. It's a very specific focus, but it usually comes at a higher cost. So why a lot of enterprises like Azure is because of hybrid cloud. So you don't have to move everything to the cloud or have everything on premise. You can mix and match and do the best of both worlds. So maybe there's some things, some hardware that you want to manage yourself, or some servers or data where you don't want it to be out on public cloud. That happens a lot in healthcare, probably happens in insurance, likely too. I know it does in banking, so insurance it would too. Those are three of the drawing a blank of the career fields or the what am I thinking here?
Sure. Industries?
Industries. Three of the industries, yes, that I know like have to have some very secure data, especially around personal information. So hybrid cloud may be a really good solution. There's okay that they're putting in the cloud, or they want managed in the cloud, and then they want some of it managed, they want to still manage some of it themselves. Usually done with some orchestration between that enterprise and third party. So there's also cold storage and hot storage. Briefly mentioned that. Cold storage is for, let me get my pointer back here. We're right here. Cold storage is really for data that's less accessed. It's on slower disk. It says when you want to access it, it's a little bit slower because it's kind of off on hard drives that aren't quite as fast, or a network connection that's not as fast. So it uses less bandwidth. It's cheaper to be able to do that, and then you still have your data there. So the downside of that is that it's slower when you try to access it. So hot storage is data that's frequently used in access, which means faster and more expensive hardware. This is if you're accessing things frequently, the faster your disk and your processing and your network is, the faster you'll be able to do things. So that's good to know as a data engineer because we won't cover it a lot here. We won't cover it much here. We're just defining it, but knowing whether it's cold storage or hot storage or some considerations and some cost savings there. And then there's a table up above. So here are the main types of cloud storage. So we have object, block storage. Your infrequent is like your cold storage, file storage, backup, and disaster recovery. So we have each one of these for AWS, Azure, and GCP. I would note on this, we'll cover it a little bit in this, the rest of this lecture, but the main ones to be interested in, the main one to be interested in are the two for data is file storage, backup storage, and cold storage. The object and the block storage are more for application, or more for application consideration. So object is like programming language, objects, and then block is specific application optimization too. And then disaster recovery is an important piece of it too. So when we think back to the very first class, Azure's not just a data platform. There's also storage for optimized storage for building and managing applications on it also. So our focus is going to be mostly the file storage and data lake storage. But it's good to cover all these different types of storage to understand it, have a better picture of it. All right. So now we are starting to talk about specifically within Azure, the data storage services. So there's four that we're going to focus on is Azure Blobs, which is a massively scalable object store for text and binary data. This is what Gen 2 is built upon. So Gen 2 is the newest version of Microsoft's data lake. It started as blob storage, which is just storing files on it. And then they built Data Lake Gen 2 to be optimized for storing and managing data, specifically like we talked about earlier. Azure Files is managed file shares for cloud and on-premise deployment, more for applications. Files that applications create and use. Azure Queries is a messaging store for reliable messaging between application components. I have not used Azure Queues myself, like I said, but it is actually part of the data storage service that we talked about. It's that storage of like messages, ordered messages for processing, especially used for real-time data. Say you're capturing data faster than you can process it, you can put it in a queue until you're able to process that data. Or you can put it in the queue and then process the data, either way. Store it there until you can process it, or just put it all in the queue and process it in the queue. And then Azure Tables, like we talked about, it's a little bit more flexible version of a relational database table. It's actually a NoSQL store for schemaless storage of structured data. So schemaless is like what I talked about, is that you don't really, you have rows and columns, but it doesn't have to be, you don't have to strictly assign it data types. Your records can be of different length. Like we'll see in an example that we have that it could be missing values for a certain field. Like, say you have a person and then you have address line 1 and address line 2, and some of them will have address 2 and some of them won't. You'll be able to store like different length records within the table instead of having to strictly define it. It's actually also really good because sometimes there's a thing that happens called schema drift, where your data profile starts changing, or all of a sudden there's a column added into your data. If you're doing that in a relational database, you potentially have to add another column to find it, maybe update a whole bunch of records. In a table, it'll just handle the column itself. If there's a new column that you're getting from an API pull, you can just insert that as is into table storage. So it's really flexible and schemaless. I use it myself quite a bit when I'm first loading data, because even then, if you load it into Azure Tables, you can look and examine it, and then you could put it in a relational database if you'd like to, and then define a schema and everything for it. So it's a really nice, using Azure Tables is a really nice starting place for me. So we'll cover that in a little bit more detail. This picture here is what I really like about these data structures within the data portion of Azure, is that they're all accessible by REST API. So we learned that in the last class. Where that's valuable is if I'm writing a script, I'm trying to get data from an ERP system or CRM system. So I write a script to get the data out of it. In that same script, I could just take that data, connect it by REST API, and load it straight into one of these, instead of having to get the file, copying it over, and having to do a bunch of other stuff. So it becomes useful in the transfer of data, or even sometimes obtaining data. Maybe you're writing code for a model and you just want to connect the table storage. So you write a little bit of code, or you can actually do that in an Azure pipeline also. And we'll learn more about Data Factory coming up, but you could access the tables that way. Also, so the APIs give you a lot of ways to transfer and access data. So file and disk storage, those are more designed for Microsoft Azure virtual machines, and I didn't realize that was my typo, because I copied it somewhere else. So Microsoft. But there's some like that, file and disk storage, more for virtual machines or applications that you're running and building on the cloud. So the big part is not only are these services built for data, is that they have REST APIs that you use quite a bit in data science also that make them handy. So those are really the four main ones, with queue, table, and blob storage being the ones we focus on the most. And tables. Yeah, yes, and tables. All right. So we're going to dive into Azure table storage. So this is where we start to get into the world of NoSQL. So Azure table storage is what they call a NoSQL key value data store that offers highly available, massively scalable storage so that applications can automatically scale as needed. So it's a new scalable database, and it stores data in key value pairs. So if you think back to your Python class, you'd have dictionaries, and then you have key value pairs. And that's exactly how JSON is designed to, is with key value pairs. So this becomes really valuable in storing data that's formatted in that type of key value pair situation. So it's designed to store a large amount of structured, non-relational data. So it is structured in the sense is that it has key value pairs, and JSON is actually a structured data source because it has values with pairs, and you're able to be able to get data out of it instead of it being semi-structured or not structured like text. It's designed exactly for that purpose. It's a schemaless design. It doesn't require a schema. It doesn't care what your columns are. It basically stores everything as text across these columns.
What's the con on that? Like, what's the negative of it being a schemaless? Like, there's a reason why we have a schema. I don't know. I mean, I'm just saying, like, what's
So the con would be is that it's not relatable. Do you remember doing like normal forms in your relational database? So where you define like a primary key so that you can relate it to other tables. Yeah. So this isn't one that you can really relate. It's just a data set in itself.
Oh, okay.
So the advantage of relational databases is where you start to connect tables together. And in theory, you could find a key in this one and do that, but it's not like strictly defined.
It's not structured that way.
Right. So this is like oftentimes what I'll do is I'll get data out of an API and it may be missing some values like history, liquidity. Like this record right here, it didn't have history, liquidity as part of its key value pair, so it just filled it in with that. So that doesn't always go very well into a relational database. Like this one probably, and it didn't really have a key either. So it defines its own partition and row key and everything. But it's not really in the place where you've tightly defined it and put a schema on it to be able to relate it to anything else, if that makes sense. Yeah. Like it's potentially relatable, but I like to do this as a first step because it could be missing values and you may have to explore the data in the first place just to see how you put it in a relational database. So it's usually like one of my first steps to do this and then turn it into something that I could use in SQL, which this works great because you could put this within an Azure factory pipeline, which we haven't got to, but you could easily turn that into a table in a relational database. Okay. So oftentimes data is very like messy in the first place, right? You're getting it out and like a lot has to happen just to get it into a table in a relational database and then create those relationships. Instead of having to do all that work, you can put it here first and then work with this and then define those relationships later. This is like just getting it to a spot where you can use it. The downside of that is that it's not strictly defined. It can be kind of messy. The quality can be low. And you may not be able to join it to anything else without that work, or it could be very difficult. So uses, I kind of talked about the uses. It's like a quick and dirty tabular storage. Has REST API access. I talked about that in one of the last few slides, is that I can get data from a REST API or a system. Then I could use the API just to dump this table into Azure table storage. And to automate the process. They say it's pretty high performance versus SQL. I'd have to see that in action, and cheap versus Cosmos DB, which I believe. One of the advantages here is schema drift. So when you have a relational database, it's just those columns. And sometimes you'll connect to like a REST API and all of a sudden they'll add a column or take it away. So instead of it just breaking that relationship in a relational database, this is more flexible. It'll just appear as another column here in this data set. So there are a number of things that can happen with data. It can be unclean. The schema could change. So like there could be a column added or removed. Oh, what else can happen here? It can be in like a format that's not really super ready for being a relational database yet, which is like a lot of the advantages of this. It's a data engineering tool, I think, just to be able to load data and then use it later. So this may not be a permanent solution, but it is a good way to be able to start exploring it and then potentially put it in like a relational database, which is why I use this a lot. And then our exercise at the end of class, we'll use table storage also. Okay. So we are headed towards the end of hour 1 here. So we're going to go ahead and define what is a data lake. So a data lake in Azure, it's the Gen 2 storage that we've been talking about. But a data lake is a centralized repository that ingests and stores large volumes of data in its original form. I put Microsoft there because that's Microsoft's definition. But one of the positives about data lake is that it's a blob storage, so it can take any type of text or binary data. Binary data is pretty close to anything, like any type of application or sensor data. Text files would be like CSV files, XML, JSON. Excel, Microsoft Excel would actually be, that would be Blob, or that would be binary file. It'd read it as a binary file and then you would convert it. But basically you can store it. Like, there's nothing that I can think of that you couldn't store in it as far as like computing is concerned. I could be proven wrong on that. It's something I'm not thinking of, but.
What images?
What's that?
Is images under the video one?
This one?
No, I think I see it.
Oh, images. Yes, it can store images because image is a type of binary file. Say basically everything that I can think of is either some type of binary file or application, like an Excel sheet or a video or like any number of things, application, a program, or it's like a text file, like literally text, or a CSV file is actually like the computer considers it just a text file instead of a binary file because you can read it directly. And there's XML and JSON files that are like that too. I'll challenge myself during break if I can think of anything, but I don't think that there's anything that you can't store in it. All right, so it differs. You may have heard of a data warehouse in the SQL class. It differs from that. That's an OLAP, so online analytical processing. So data warehouse is like a highly structured, like relational database data store. So that has its own value. It has like, it's very like strictly defined. You have business rules in it. You have like your facts and your dimensions and your business entities and everything that you want for like reporting and analysis. But there's this whole like new breed of data almost that people use for analytics past the traditional data warehouse. The traditional data warehouse still has a lot of value in itself, especially like storing historical data and metrics and things like that. But now people are doing like AI or machine learning on videos or text or semi-structured or unstructured data. So the data lake comes in really valuable there, or even real-time data that may not be that well suited for a relational database also. So a data warehouse is like, or a data lake is really flexible, and that's how it differs from a data warehouse. You now have the concept of ELT versus ETL. And traditionally in a data warehouse, you'd extract data from a data source, you'd transform it the way you needed to and load it into the data warehouse. Whereas ELT, now you can just take the data and load it there and figure out all of your transformations later. That becomes useful when you're collecting data, but you haven't figured out what to do with it. Or there's a data source that you use but you may end up finding another way of using it later. You may have a new machine learning model, and you may transform it differently. So the data just lives there to be able to be defined or transformed later, which can be a blessing and a curse. You can store too much data sometimes, but I personally like ELT because oftentimes business is moving fast and the rules change, and it gives you like the data sources there, and it's really a flexible way of defining data. and centralized way of doing it. So you all bring it all together in a data lake, which can't be underestimated, so you don't have all sorts of different types of sources of truth. The use cases include machine learning, predictive analytics, AI, real-time scalable analytics, undefined data, so data you want to use, you just haven't figured out what to do with it yet. And then text data would be one of the biggest. So whether natural language processing or generative AI is like the newest, coolest thing, but that's all about text data and making sense, processing and making sense out of that. And then AI is like intelligently responding back to you. So really the data lake is like for this whole new breed of like data analytics and advanced analytics and AI and machine learning in real time. That's probably really only been around for maybe the last 10 years. Otherwise, it was more of traditional relational databases and traditional metrics. But the more and more data that is generated, the more people try to find ways and things to do with it. And data lake is a good solution for that. Right. So Gen 2 is Azure's solution for data lake. It's built on top of Azure Blob storage to provide and handle enterprise data and big data analytics more effectively. I think that's really like simple and good way to say it. It's storage that's part of the entire data ecosystem that they've built specifically for big data analytics, so huge data sets, whether structured or unstructured or real time. They build it to be able to handle those cases specifically. All right. So the key features of the data lake is hierarchical namespace. So don't think too much of that fancy name. It's really like how your file system works, like on your Windows or your Macintosh. So it's like very intuitive. You have folders. You actually have like an account and you have folders and then you have files underneath of it. So it's just like a hierarchy. Like you'd have like your C drive on your computer where you have your home and then you have folders and you have folders within folders and then files underneath of it. It's highly scalable. That's designed intentionally with the idea of the data and it's growing and needing to be able to store and process it. And then integration with Azure services, that might be the biggest one of them all, other than scalability is too, but that it's integrated with all these different data processing platforms that we'll learn about, and it's made to be efficient within those. So you're able to do things that you weren't able to do at even a potentially like lower cost of doing it. And then I wanted to show this because I wanted to show where the data lake really lives within the ecosystem. So data lake, so you have your systems here over on the left or your files. So you have your business applications files, your log data, and then you're uploading those. I often upload those into data lake, but you can also use Data Factory to get those files, and they call it ingest, which is like your extract, transform, or load, or your extract, load, and transform. You can take that and put it in the data lake, and then you can reuse it in whether you're doing data analytics or you're doing some advanced like analysis and data warehousing and storing that in data lake. And then you can eventually that final product becomes Power BI dashboards usually, or some other type of application. So storage is really like, how would I say it? It is across the ecosystem and used for whether it's ingesting data or for analytics or for the final product before it goes out to BI, being able to store all that data in one central repository. So then there's never it comes from the data lake, you know where the data comes from instead of it being all over the place, which happens sometimes. All right. So that's actually the end of talking about storage. We covered out quite a bit there, just from cloud storage in general to data storage services and table and data lake. In the second hour, we'll learn more about the databases within Azure, and then what does NoSQL actually mean. We'll dive deeper into that. So go ahead and give everyone a break. Be a good time to work on the quiz. I'll give everyone 15 minutes. We'll start again at 7:30, and then that will put us on track to do a hands-on exercise about 8:15 or so. So we'll go to 7:30. I'll give people time to finish up the quiz, and we'll be back, learn more about Azure databases. All right. Just about to get started again. We have 8 responses for the quiz now, so that's the majority of the class. I think maybe we just have two more left. Oh, you did? You already did? Yeah, we have John. He said he'd do his later. So we'll dock him a couple points for it. Yeah, I'm just joking. Just try not to cheat on it. I know John, I had him in the last class, so I think
You're not
it's the
talking
same
this
John
John,
that
are
you
you?
got. What's that?
You're not talking this John, are you?
No, I'm like, wait a second. Let's see. Before I start to badmouth anyone, let's get it straight. Get it straight before I do and get myself in trouble. John K, I had him in the other classes, and he's like taking 2 classes at the same time, and he's like on the road and everything. Like, just don't cheat and get all the answers and hand it in. But all of these homeworks are really not that strict on them. I give feedback and do pass, no pass, but just to make sure everybody's learning those skills. I think said that at the beginning of class. So even if it's a little bit late, better than never, of course, and it shows what you've learned, and I can provide feedback on it. And then at the end of the class, determine if you learn the basic skills you need in the class. Basic close to everyone, I'd say close to, if you put the effort in, gather feedback, and you'll be all right in the class. All right, we're gonna go ahead and get started. I did bring, let's see, something interesting up about blob storage. I was just curious myself. It seemed to me that basically blob storage is like everything, like a computer would store, because either it's like a binary file of some type, like ones and zeros, like that computers, machines will be able to read and interpret, or it's a text file, which is like everything, which everything the blob stores. And I think that's correct. Like, well, I'm pretty sure it's correct. It's because blob storage, you can technically store everything, but it says there may be some restrictions or limitations depending on the configuration or policies of the storage provider. So it'd be more about them like restricting what type of files you can store, not like a blob container itself. Like a blob in theory can contain everything. Like one of the types I talked about is executable files. Some of them might restrict that, like an exe file or some like application, because they could like be like malware or something, or they detect it. The network providers or these providers probably don't want you to store and execute malware on their systems. Not usually used for temporary files. It's more persistent storage. If you're doing temporary files, there's probably other better storage that you can use in blob storage, hot or cold. You might do it in a database, or you could use one of the file stores instead. And some of like the personal cloud storage, basically like Box or Google Drive, that's a type of blob storage really. It's like you can store files or pictures or text files and stuff like that. They'll have like size restrictions on it. Azure really doesn't, because they'll just charge you for how much you store. So, and big data often gets into the gigabytes or even the terabytes of data. So not as much of a restriction for Azure. Proprietary formats, that's more probably like a preference of whatever cloud storage provider. And you don't want to, you still, I mean, Azure is, and these platforms have done a lot around like personal identifiable information and HIPAA, but there's still potentially like healthcare records. Like you may or may not be able to store those or want to store those in the cloud also. So it's more of like considerations or the types of files that whatever service provider doesn't want you to store there. But of course, if you have a private cloud, like we did with the managed service provider, they personally deal with being able to handle this type of information. So it's really like it says here in Chat GPT. I thought I asked it a silly question, but it ended up not being that silly a question. All right, we'll go ahead and get started with the second part of this lecture. We'll go through it fairly fast because half of it's about relational databases. So the relational databases you learned in MySQL 101 is, they're tabular storage with, you identify a primary key or a foreign key to be able to relate it to other tables. And instead of just store structured data, I'd say highly structured OLTP and OLAP data. So your transaction systems like your applications or your data warehouse type systems with OLAP. And here relationships across tables queried using the SQL programming language. So that would be one thing, Brenda. One disadvantage of having it in a non-SQL database is that SQL doesn't work as well with it if it's not a relational database. SQL is a programming language specifically meant for querying and joining and relating relational database tables. One of the purposes of SQL programming language. All right, so what are the properties of relational databases? Like some of the things you learned in the data management and manipulation class. So you have a database, that's a large container filled with tables and other database objects. You have the tables, you have fields and records. Fields are your columns, records are your rows. And then the schema is how a table or database is organized and designed. So tightly defined schemas here to be able to get these into the normal forms that you need to be able to relate them together. So it's highly structured, and sometimes, like I said in the previous hour, sometimes that's a lot of work to be able to get the data into that type of highly structured table. Like you have to clean it, you have to make sure it's distinct on a primary key. Your primary key, it's actually distinct. Like each row is actually unique in the table. Or what are the other first normal form properties off the top of my head? The column names are proper. There are a couple others too I can't think of. The order doesn't matter. Sometimes data will come in a sequential data that actually matters. That's where the other type of table storage might be better for it. Because in a relational database, the order of the records doesn't matter. Not bad I just taught the class, that's why I remember that, but not bad off the top of my head. But it takes a lot. The key is that it takes a lot for a relational database. You may have to do a lot of work to get it here. Once you get it here, it's great because, it's tightly defined. You can start blending and merging data. You can relate it. You can define business rules and OLAP data and everything like that. And in transaction processing systems, you can effectively capture data. So still very much used in analytics and business intelligence. All right. And part of data engineers' job is to then set up these type of structures. So non-relational database is really talked about for data lake, all of this, semi-structured or unstructured data, or maybe it's structured data, but it's not in a format that's ready for relational databases or tables. Some of these, probably I'd say the most commonly, and I've used it before, I don't use it a lot, but the most common are these document databases. Data is stored in documents instead of rows or columns, and these documents are grouped together in collections. So these are like contact management systems, blogging platforms, and e-commerce applications. So this would be like JSON can be structured in this way also, not just key value, but documents, especially with like nested data, is a good use for it. So say you have a bunch of you have information about a certain user in a system. So you get that JSON, but then you have like their accounts underneath of it or something, and maybe they have multiple accounts. So it's like to flatten that out, it would take a lot to create it in a relational database, because you may have to have user and account number 1, account number 2, account number 3. You can actually do that in a document database and then start to refer to it by customer schema and stuff like that, or customer and account and things like that. So really valuable for nested data that comes in JSON format. Usually what I end up doing, I usually end up just parsing things out and putting it in a tabular data structure, because it's what I'm most used to working with. But it can be useful, and I have used it before in the past, especially if you're just trying to capture a lot of data and it's in a format that you can use, or a format like a nested JSON format that lends itself well to document databases. So key value is like, it's really pretty similar, except that's just like what we saw with Azure Tables. Azure Tables is a key value database or storage unit of storage. I'd consider that. So a key value, it takes your record, like a JSON record, or like a dictionary. Think about a dictionary and how JSON is structured. That flattens it out into like a table-like structure. You have your key, and then you have your values related to it. So like I showed you in my Data Explorer, I'll pull that over here. Data Explorer, Storage Explorer. Let me pull this over. What you can do is go from, get this to look right. So this actually started as JSON file. I got this on, our exercise will be over Bitcoin and crypto related data. But it started as JSON from an API call, and then it created its own row key and partition key with the related values on each one of those keys. So key and then value pairs. And then it flattens it out into a table structure. So actually also very useful in the sense that, like I said with Azure, why I use Azure Tables a lot is because it flattens it out, starts to help flatten that out into that tabular structure that I like working with. There are also databases that do that itself. So in Amazon, it's DynamoDB, and it is a part of Cosmos DB within Azure. So the use for it is suitable for storing session information, user profiles, and configurations. So information about users, it can be flattening those out in a table. So like each record is a user. I haven't used key value pair databases yet, but could be useful, especially if you have a lot of data. I guess it's really the same for document and key value data. Does the data get to the point where you need like a more efficient data store for it? My answer itself is almost always no, but it could be to a case where the data is so big that maybe you want to load it into key value database or a document database. Right. So column family, this is like really hard. It's hard to explain. Like I was having a hard time. I never use them. I was having a hard time even wrapping my mind around how I would explain it. So it's effective for analyzing large data sets, just as Internet of Things or user event logs on. Take a quick look at this. Try to do my best. So I provide a link in here if you want to learn more. So they're like, you define like a key on the family. It's kind of like a unique record, and then you have like column families within that key. So they'll give you an example here. So like your key would be Bob, and then like you have columns for email address, gender, and age under each one. Each row can contain a different number of columns to the other rows, and each column is contained to its row. So like here, this is probably the best value. You have like this name, value, and timestamp of when it's created. Probably best for log data. Is that what it says? Yeah, user event logs. I haven't worked a lot with log data itself, but there are definitely a lot of applications for machine learning and AI that use log data. And then there's graph. So Neo4j and MariaDB. Haven't used this itself, but one of the applications is I know Meta uses. I think Meta created Neo4j for its social networks. So like all those different relationships, it's like a big spider web or a big graph. So a graph is like a bunch of nodes and lines connecting things together. It's a more efficient way to get to all of those different relationships than a relational database would be, because there are literally like millions of different relationships between people. Like even one person, you could have, say you have 500 friends, and those 500 friends have 500 friends, and you see like how it just multiplies itself. So like graph DB is for that. Being able to do that, I guess it's used in fraud detection and recommendation systems. I'd have to check that out. Those are interesting applications of it. So let this all be said that out of all the data engineering work I've done, this is probably like, I've used this like 1% of like the data out of all the data work, but this is like, these are like these special use cases. Like NoSQL will have like their special use cases for like, they're mostly big data technologies for being able to handle like just the massive amounts of these types of data. So the people who have these skills, it's like pretty rare, but the jobs are also pretty rare too. It's like machine learning engineer, AI engineer, some type of big data application engineer. To me, like it's good for me to have an awareness that these things exist in case I ever need them. I think that's a lot of what the class is also, is like just bring it like this class is giving you the information. So now you even know where to look. So the NoSQL non-relational databases are largely like use case specific with document NoSQL databases. That's the ones I see used the most, even by development teams. MongoDB. Okay. So Azure Database Services. So that's all these things across the top. We'll cover it, Synapse Analytics in more detail in the upcoming lectures. But you have Azure SQL databases. So these are the relational databases: Microsoft SQL, MySQL, Postgres, MariaDB. We won't cover it in much detail because setting up these services it's actually really pretty straightforward. And once you do, it's just like basically how you use the databases in your SQL or your data management and manipulation classes. They have almost all of the same functionality. The MySQL database is actually the one I use to teach that MySQL class. I use Azure database for MySQL. And that's what everybody's using in class, that you have like that shared database that people work on. So knowing that those exist are super easy to spin up in as a resource in a resource group. And then Cosmos DB, so we'll cover this a little more because it contains all of those non-relational databases or the NoSQL databases that we learned we covered in the last slide. Plus it also includes Postgres. So it's on the Cosmos DB is like they call it a multi-model database, which is kind of true, but it's almost like a platform that contains like all these different types of databases, and it has its own storage too. So that will bring you into Cosmos DB. So why would you use Cosmos DB? Fully managed like the other services in Azure, globally distributed. So it's a database that can exist across all the different regions. Consistency, so it has data consistency choices across the different databases. Scalable, of course, that's one of the best properties of being in the cloud, and then it has all the different databases to be able to do that. Highly available, multi-model, supports JSON documents, table graphs, and columnar data models, which also Cosmos DB supports Azure Tables, which is good. Common use cases for it. So one of the nice features of Azure Cosmos DB is that across these databases or their data store, it has a SQL-like query language for JSON documents. So that's useful because instead of having to parse through the JSON document, you can use the query language instead. Some of the other use cases are web and mobile applications, require global and horizontal scaling. So if you have like an application that you want across the world, distributed across the world, or you want to be able to scale like multiple compute resources, it's very scalable resource. Internet of Things, it can process large data streams in real time, so it has real-time capabilities. And then real-time analytics and retail and e-commerce, especially for loads that go up and down. So like, I haven't used Cosmos DB myself. If anybody's interested, we could go into Cosmos DB in more depth in this class. But the key thing to know is it's really like it's almost like a platform, an all-inclusive platform of these different databases. It's how you would use the different NoSQL databases in Azure, is that you would install the Cosmos DB resource and then use the document stores, or you use graph DBs and things like that. Now, Azure Tables, you can use that outside of Cosmos DB, which is just something that's available along with the Gen 2 storage. But for this class, we won't touch on it too much here since it's an overview. It's like its own, almost like we could do a whole class on Cosmos DB probably itself. But knowing that it exists and being able to go to it if you need, especially like NoSQL databases, is good to know. All right. So Azure Storage Explorer. So we're going to install Azure Storage Explorer. So it's a free standalone app from Microsoft that lets you work with Azure storage data. So your Gen 2 storage. So you can see here you have the application. I have my subscription. Then I have my data lake or Gen 2 storage, and you can see the blob containers or file shares. And then you have the queues and tables data structures in there. So tables and queues are usually part of Gen 2 storage. But it gives you an easy way to explore it. You can create new folders or storage containers and put files in there. And then it gives you messages on if the transfer was completed or not. Different properties. So the URL, these files will actually live at a URL that you can access, and what type of blob container and stuff, and then a bunch of operations that you can do. So anything that you can do with a regular file store. So like upload or download, create a new folder, select all, delete files, copy paste, like the usual things that you can do with like a directory type structure. So this tool provides user-friendly interface, key features. You can have multiple accounts. You can see I have multiple accounts here in my JB Analytics. I actually use this for some of my own BI stuff. Browse and modify storage data, view and edit blob containers. So you can create new blob containers. Queues, tables, and file shares. You can create new tables underneath of there. Security data management. This is probably one of the better ways to manage security. So you can go in here and manage who has permission to certain resources or not through the security protocol that Azure has, RBAC, I believe it's called. Has access to Azure Cosmos, so you can explore like the data storage that Azure Cosmos has. Security encryption and generates shared access signatures. So it's kind of like a shared link. What you can do on these files is create an access signature and then give somebody permission to, if they have that access signature, to be able to view certain files for a certain amount of time. So you can control that. It's like a key, like an API key or like a public key that you can give to someone. And as long as they have that public key, they can access it for a set amount of however long you set it to work or be expired. Usually like under these lease states, you can unlock and you can set a certain lease on it. Right, so a lot that you can do, and it's really like probably the best way to get around. It's the way I always get around data lake instead of. Yeah.
You said like that, those little individual documents you can like send them like here or whatever, can you send it in like a folder? Like if you had to send all 4 of those things, could you send them like at one?
So you could, I believe that you can download a folder here. Let me double check that though. Let's go ahead and give it a try. Pull over Storage Explorer. I have a example loaded up. So if I wanted to download this, can download all the files. Let's see, can I download the folder itself? So you can do the acquire release like I talked about. That was different. Clone it. So what you're asking Anna is, can I just download the folder?
Or like
So-
share the folder instead of like each one?
Yeah, you could acquire a lease on this. Or am I looking at the wrong thing? If you get one of the shared access keys, get shared access signature. So get a shared access signature. One access policy. You have a start and end time. You can give them what type of permissions that you want. You can create, and then you can see it's to that location in my data lake, my blob storage data lake, and then to that folder. And this may look familiar because I believe that this is an API call itself that allows you to do this, and then your signature, your key is within one of the parameters. So they could see it by URL, or they can connect to it by this token. I'd have to remember how another user can access this using this token, but I know that it's possible. If they have this token, then they can view this folder inside of Azure Storage Explorer. But I haven't done it in a while, so I have to remember how that's done. But it is possible. I've done it before. So it's kind of like a shared link, but it's a shared key instead. All right. So useful, especially if you just want them to, if you only want them to see it, you don't want them to see everything. You just want them to want to share certain files with somebody. Usually, one of the things that we aren't covering a lot in this class is, if you're this type of data engineer or even like an application developer, one of your considerations is going to be security, like who can access what or what applications can access what data and so forth. But security is like, security is its own creature in Azure, but important to like recognize, like probably especially like best practices, like just one of the security practices in general was the idea of kind of like the least needed access. I know there's a specific word for it. Kind of like need to know. You only give them access to the stuff that they need to do their workflows or do their jobs, instead of just giving them access to everything. We're just saying, here you go, here's access to everything in the data lake. So that's an engineering security is an engineering consideration in itself, whether it's data or engineering applications, being a software developer, engineering applications, systems engineer. Right. So last The other tool that we're going to look at tonight is Azure Data Explorer. So Azure Data Explorer, this is a resource within Azure. It's designed for real-time analysis of large volumes of streaming and stored data. It excels in scenarios that require quick insights from data streams or data lakes. So why I'd install this, or why I wanted to look at this tonight, it's not exactly storage, but it allows you to connect the data lake and be able to intake data and like query things that are in the data lake and use it as information. Reasons to use Data Explorer: interactive analytics. It's really useful in data variety that you see within a data lake. So you can process structured, semi-structured data and textural data. So it has a wide variety of query utilities to be able to get information out of that type of information. It's good for data velocity, so real-time data analysis, data volumes. It's good on big data and organizing and query concurrency. So like you can have a bunch of users querying data in here at the same time and it still works well. One of the biggest things that I think this platform is good for is it's kind of a data quality tool, is where you can set up reports for this data to monitor data, so like certain things happening in the data, like how much data is coming in, or is the data consistent, or does it have errors in it, and things like that. You can monitor that directly in the data lake. So we'll see that in our exercise. This graphic over here is how it's positioned within Microsoft Azure. So you have all this incoming data. You usually use, like out of systems, you'd use Azure Data Factory, and then your Azure Data Lake, you'd ingest from Data Lake. You use Synapse Analytics to process some of it, but it takes in some of that data that's not as, I'd say, not as big data like. It's like smaller data files are not real time, but it also has the capability to take in event data, Internet of Things, and I forgot what Apache Kafka is, but that's a big data technology too. Probably graph data from that picture. And then it takes streaming data, it mixes it with your pre-existing data to be able to create custom applications like AI applications or Power BI. I don't remember what Grafana is either. There's so many emerging technologies and these things, I can't even keep up myself. Especially in this whole new wave of AI and machine learning is its own creature. Even for, I'd consider, as a data engineer, your job is different if you're engineering AI and machine learning solutions than it is just like traditional business intelligence and analytics. They're like these NoSQL technologies or real-time streaming and unstructured data processing and stuff like that. Really interesting to get into, and you can be paid super highly if you can find your way to get into it. But I don't think people even believe that I do that type of stuff. So it's really super hard to get into, and the jobs are pretty rare. I mean, I don't know. Maybe somebody's doing it around Omaha that I don't know of, but I feel like that's stuff that's usually done on like the coast or Silicon Valley and stuff like that. But once again, good to know this stuff, and you could use Synapse Analytics just for some real-time streaming event. Synapse Analytics and the Data Explorer that we're using. Data Explorer is what we're using, but it's also within Synapse Analytics, which we'll learn more about. Synapse Analytics is really a cool tool for taking data and being able to view advanced analytics out of it, and data warehousing and advanced analytics. All right. So that's that. Additional resources. I got all these from Microsoft Learn today. There's just a wealth of knowledge. I'd say got it from a combination of Microsoft Learn and ChatGPT. So introduction to data storage, table storage intro, getting started with Storage Explorer, Data Explorer. Data Explorer has its language. It's SQL-like, but it's called KQL. So there's some translations in between that we'll actually see this in our exercise that we do tonight. I haven't used it a lot myself, but of course, knowledge is just at your fingertips, right? You're only a Google search away from knowing just about or figuring out just about anything you need to know as an engineer. So like if you have a table, something in table storage, instead of select star from dependencies, you just say dependencies. They have different keywords and syntax, right? So dependencies, they have take 100 instead of top 100. They have the where conditions, and then they apply functions to it and stuff like that. Between has regular expressions, so forth. They do this, but usually because, like we said, a lot of these data sources, they aren't in like relational database format that SQL applies super well to it. So they have basically have their own languages to be able to query the data that's in the database. Even MongoDB with the document store, we didn't cover it here, but it has its own like little query language to specifically query like nested documents within the database. So when we use SQL, SQL's really specifically for relational databases. The beauty behind that is SQL is super powerful once you get things into relational database format, but not everything is quite in that format yet, which is why you have these alternative query languages, or sometimes they'll call them like SQL-like languages where the syntax is similar, but it's just a little bit different for whatever you're trying to do. All right. Before we take a break here and do our exercise, I wanted to cover the quiz. Quiz answers. So we'll pick on John and go over all his answers. No, we won't. Just teasing John. All right, so had 9, so that's pretty much entire class. I think we just have one left over. So why is cloud engineering important? So I didn't tell everyone this before the quiz, but you're welcome to do open notes because that's like that's like the way. Yeah, I got a couple frowns here and stares personally, but that's the way engineers do it. So like, you know, you can use any resource you have or go back into the lecture notes. I don't really mind, and the final is going to be like that because some of the final questions are also going to be from the certification exam, but some of them will be like this. I did today too. These weren't from the certification exam because the certification exam doesn't really have a cloud overview and it doesn't cover API related data. But starting with the storage data, that's where they start to have more of the certification questions. So starting this week and then onto the final, we'll have more of those type of questions. But for this week, it's really questions related to class 1 and 2 out of the notes. So be resourceful. Feel free to use open notes. Not open partner, what they said, as much as anything. So wanting to do your own work, but open notes is fine with me. That's how engineers do things. So why is cloud engineering important? This one was from the notes. I left one out is to conduct the advanced analytics and create cutting edge AI models. That's more the job of the data scientist, but the engineers do help data scientists implement cutting edge AI models. And don't worry too much if like you miss that one of them out of all of these and everything. I give partial credit on them, and it's more of a pass no pass thing anyway. All right. So, what was the second question? Oh wait, that's part of the first question. Hold on, I need to scroll to the second question. Okay. This goes question by question. Okay, that's why. All right, the four main components of a cloud data platform. We covered this in the first lecture. So the answer is storage, processing, compute, big data, AI, and machine learning. So did I put 5 there? And I said 4. So compute and AI and machine learning. So I would X out big data, although big data is like part of why cloud platforms are designed the way they are. So I must say I forgot to take that out, and you had 5 answers there. So don't worry if you got that wrong or anything, but you'll see the rest of the class is pretty much designed this way. We're covering storage today. We cover data processing next. Next week, we'll start to cover compute and AI. It even covered a little bit of big data in this class. All right. So what are the advantages of using cloud data platform? There is an all of the above. Let's view all the options. So actually all of these, I made it a little tricky, but all of these were advantages of using cloud platform. We've been over it a bunch of times, but scalability is one of the biggest. Hopefully you gain cost efficiency out of it. If not, you probably reevaluate and do a hybrid model, or maybe not go to the cloud, depending. Accessibility, availability, and reliability. Highly reliable, able to access it over the internet, basically 24/7 with an internet connection. Flexibility and manageability, especially with fully managed services. Security and redundancy is part of it. So secure protocols and things like backup and disaster recovery is huge. So you don't have to do those things yourself. So all of the above. On question 3, what is the role of a data engineer? Let's see if we have a good one here. Data engineer's role involves designing and building pipelines, managing databases, optimizing systems for performance and scalability, ensuring data quality and governance, collaborating with various teams to support data-driven decision making. I think that's like a pretty good definition. Like it's all of the above. It's these engineering tasks. You're now like building data and managing data pipelines and databases. So you're part engineer and even part database administrator. You're constantly optimizing these systems, sharing data quality and governance, helping with that, and collaborating with various teams. So it's really like you're never like doing data in a vacuum. You're always working with someone, whether it's a data scientist or a data steward who's helping you to find data and making sure data quality is there. Oftentimes as an engineer, you're implementing these things. So what did we officially say? I kind of winged it there as far as what a data engineer was, but that first definition, whoever put that that's a pretty good definition. Then I think we had a definition somewhere here in class 1, but I can't find it right off of the top of the bat. I did put it in one of the first profile. I know I did that. All right. In cloud computing, what is a data engineer responsible for in a managed service? So I made this a little bit tricky. So in a managed service, it's fully managed service. You don't have to worry about maintenance and software updates. I did see someone put security in. You could make an argument for security because some of the role-based access is like part in Azure is part of the data engineer's responsibility. I was thinking of security in terms of having to configure it within like the database itself. So the platform does its own like managed services security, but you're also as an engineer responsible for like security as far as like role-based security, or as a database administrator you still have to like grant access to people and stuff like that. So I did take a quick peek and somebody answered that, and I think I would give you credit for that answer.
I was going back and forth with that.
Security. I could see where you were coming from with that, or anybody else who picked that. So in general, the platform manages the security for you, but it's your responsibility to also define that, like for what that means for your organization in the cloud. And I think probably, yeah, there are a couple people who did that, like security. All right, so what is subscription management hierarchy within Azure? So what that was is starting, I wanted to start from top to bottom level. So the highest level is like a management group. So that's like a department within a company, different management groups potentially, or it could be defined a number of ways. So then you can have multiple subscriptions within the management groups. So those are like almost like billing accounts. And then you get billed for the resources and the resource groups that you have underneath of it. So the resources are what you install, whether that's data lake or databases or analytics or machine learning lab or whatever it might be. The resources group them together into logical groups to be able to organize them. You may just have a couple of different applications, or you may have BI versus system or whatever it might be that you want to group those differently. Even if you have multiple resource groups, those will roll up in the same subscription. So I saw somebody put this answer that was just the reverse order one. I meant for it to go to top to bottom. All right, in your own words, what is an API? Further capabilities. So a set of functions made available by a resource and allow that for adding further capabilities to another resource. Pretty much, it's a way for systems to hook and integrate into each other, so data can share between platforms that may not be written in the same language. I like that definition. The combination of the two definitions is good. So it is a set of functions available by a resource for adding capabilities to another resource, but they also are a way to hook and integrate two systems or a program to a system together so you can share data, and that they both speak the same language that way. So I'll go back through tomorrow and I'll provide feedback on all of these. What are the different types of APIs? Yep, they were almost all of the above. I think I threw a couple others in there. This one was out of the notes. So anything other than like the systems itself or the programming language, I just threw a couple in there with all the other correct ones. So you have SOAP, RESTful, GraphQL, RPC, library-based APIs. They can also connect systems together, and oftentimes the system providers will give you libraries to connect systems together or webhooks. 9, what are the 4 methods? Delete, post, put, and get. Those are the CRUD methods. Create, which would be like a post. Update, which would be a put. Select would be a get, and then delete's delete. And then what are the required components of a REST API call? I made this kind of tricky. So there were only 2 that are actually required, so that's why I put it in. I put it in caps. So you need 2 things. So you need to define a URL endpoint, and you need to send that request to the URL endpoint. So headers and parameters are both technically optional, although in a lot of REST APIs, you're going to need headers for things like authentication. And you also need to send some type of JSON response or JSON data as part of the body to tell the API what it needs to do. And almost always you're going to have to find documentation on the endpoint usage, although not required technically. So kind of I made this one tricky as far as the required keyword. So we'll see how everybody did on it, the question, or if it's one that I even use for next time or not, or if it just makes people angry. I don't want to do that. I had 1 or 2 of those questions in SQL class that just made people angry. All right. Say describe the process for obtaining data from a REST API. So this one would have been hard to do without the nodes. So part of it would be documentation. Let's see if I can do it off the top of my head. Documentation, you probably go there first just to navigate yourself and see what all the endpoints are. You get the endpoint URLs. I think then you would want to get any type of, I better just look at the notes myself before I tell everybody
I know,
around.
I know how to do it though.
I think I do it, I look at it and I do it intuitively. Oh, let me bring that up. I think the other thing I'd look for, like I'm just describing my process, is like you'd look for all the parameters, what you need to include in the header and the body. Then you need to send the request, and then it would return a request, and then you would parse the information out that you need from that. Let's see how close I came. I need to pull up the second lecture. Bring this over. But the process, I thought it overall is pretty good. It's the process I use. And I like to just cover this just to remember where we've been and what we learn next week and how it builds on what we are currently doing. All right, define the endpoint URL is the first part. So defining request parameters and headers. And probably also include like data in the body. What data are you sending in the body of the request also? Then you send it. Send the request, whether it's a get, a post, put, or delete, to the specified endpoint so it knows what operation you want to do. You pass all of those as arguments, URL parameters, and headers. And then also some payload or data. That made it worse. Okay. So then you receive the response. If it's, you can check to see if the response was successful or not or first. But usually you'll know if you get the request back or not. But checking the status code is good, especially if there's an error. And then finally, you receive the response, and then you parse it using the JSON library. Now, an option is that now that you know the data lake, you could just upload that data lake, that file into the data lake, and then parse it with the tools that you have in the data lake. But you can also do that with, for this first exercise, we did it with JSON library. So it's pretty close. All right. So that is the quiz. We have 30 minutes to work through everything. I'll give everyone a 5-minute break. But one thing, because I think that we can get through this fairly quick, the exercise fairly quickly. But two things I'd like for you to do is to download Azure Storage Explorer. You can, oh, going so slow. Yeah, if we just Google Azure Storage Explorer download. This, like the other ones, it has versions for Mac and Linux and Windows. I don't think that's the one I actually wanted to go to. I'll go back. To go get started with Storage Explorer. Download and install. Okay. Download and install Storage Explorer. I'll actually just copy and paste this link in the Slack. Get you there faster. Go ahead and go to that link that I've pasted into Slack. That's the link that I'm currently at. And you can download Azure Data Storage Explorer, and then it has the Windows and Mac and Linux options. I also need to give everyone the files that we're going to use. And then one other thing to do. You actually don't have, I think I told everyone that you had to install the Data Explorer resource. It's actually not, you don't have Explorer.exe. You go there and it will ask you to set up the free version of it. And you can do that with your Azure account. I've already done it with mine, so let me see if I can give you a good example. and we'll use Data Explorer. You'll end up on a screen like this if you go to Data Explorer, and it says public free cluster, and then it'll say welcome to Data Azure Explorer, turn it into insights, create a free cluster for you to explore your data. And then you,
Signed it. I don't know if it's signed it.
yeah, you might already be signed in by your Google account if you have one. So you can skip it and sign in. So what I did is I went here and did my cluster name, which is just, or this is Data Explorer. ODSA. Since I took it, you might have to do a different one, and I just called the database the same thing. Created in North America is probably the best option. And then you can sign in and create cluster. And for anybody, if it asks you, I don't know if you have to use your Microsoft Authenticator or not, or if you set it up, have to set it up.
So you signed in, you still need to do a cluster, so what you're going to say.
Yeah.
Okay.
And it's a free cluster to explore your data, so you won't be charged for it. So Microsoft, I give them credit as and I think I said in the first classes, they have always been pretty willing to give like people who are learning stuff for free because they want you hooked into their products. So that even goes all the way back to being a college student and them giving me like Office for free and then Windows XP for like $10. That's how old I am. Because they want you to learn it and get hooked into it, so they're willing to provide training and free stuff. Then you're on their platform for life.
So for the Azure Storage Explorer app that was downloaded, do we sign in with Azure at that point too?
For what's that?
You had access to download your Azure Data Explorer, didn't you? If that's on the browser.
Oh, so there's Data Explorer, and then there's Storage Explorer. I know they're close in name, but I was confusing them today. So
the Storage Explorer, you want us to sign in with our credentials as well, correct?
yep. So once you install Data Explorer, let me back out of this so you can see what I did. Go ahead and remove it. Okay, so you'll probably see something like this as you install it. You won't see like these tabs, of course, but you'll go down to the person icon, say sign in with Azure.
So do you use Azure Storage Explorer, not Data Explorer?
We'll need both.
Okay.
With the
Storage is the one that's downloaded.
Storage Explorer first is this application.
Okay.
Data Explorer is you go to dataexplorer.azure.com. I know I was putting this lecture together and I kept confusing myself between Storage Explorer and Data Explorer. And give everybody like a minute break here since we're going fast here. I'm gonna get a drink of water and I'll be back in a second. Anybody who's installing these, let me know if you have questions, and then here in a minute or two we'll start working through the guided exercise for today. I'll be back in just 1 minute. Okay. Okay, CSV files for data lake storage. Okay, so I have three files. Three files I placed in Slack that we'll put in our data lake. So if you haven't made it all the way through homework 1 yet, you may not have data lake installed. This is where you could just go ahead and probably install that resource. If you have made it through part of the installing the different resources, they likely already have a data lake that you can gen to, data lake storage that you can connect to. If not, I'll show you how to get there. So one way you would know also is that it would show up in your Data Explorer. So this is where inside your resource group, you can create I just type like Gen 1 storage. Let's type in data lake instead. Oh, why don't they see?
Yeah.
Let's do this one instead. Storage account. Because it's under storage accounts. You have to go there. Type in up here if you do either data lake. It'll show storage account there, or you could just up at the top do storage.
Once it's classic and once it's, yeah.
So you want this one and not the classic because this is generation 1 storage. So there's Gen 2 is like the advanced version, like the optimized for analytics version. And then if you have one, you already see a few of them in there. Like I already have a couple data lakes installed. If you don't, it's a good time to create under your subscription and resource group. You can create, so there's a resource group. All of the default settings are fine. Data protection, encryption, tags, review and create. I feel like I forgot a name for this somewhere. Like that doesn't seem right. Storage name account. ODSA data lake. Of course, I already took that name as first to it. You can put numbers behind it. put it in the region. Standard is just fine. Just a general purpose account is all we'll need for this class. We could even see options in there. Okay, so standard geo-redundant storage means that it has backups. And see, we talked about hot and cold storage. There's an access tier of hot, so it's all highly available data. Has all the settings. As you can see, the more and more you learn about Azure, just the more and more you can finely tune and configure these things. But the default settings pretty much work for us. So that's where I created ODSA Data Lake 222. So now when you go in and sign into Azure under Azure Storage Explorer, I'll sign in with Azure. Yep, just regular Azure. I'm like, those don't look like the right options for me. Okay. Says it's going to redirect me. Redirect me somewhere. Oh, here. It's on my other screen. Okay. So it redirected me to sign in. Okay, you can return to Storage Explorer. Okay. And now you should see your user, your account, your subscriptions. Actually, I have 2 subscriptions. I want to use the one just for ODSA. And you probably only have one. We'll open Explorer. You'll see these options. Don't worry about the emulator and attached. You can actually have a development environment on your own computer if you wanted to. I hardly ever do that. But you want to open your subscription, and then you'll start to see all the storage accounts in that one that I just set up, and you'll have something similar. And then under the data lake, you can do file storage. I haven't used file shares myself, but you can do queues. And I've also created a table for this exercise.
Yeah, and I have storage account, and it was like, keep saying nope, nope.
Did that work for everyone? The storage
Well,
account?
It's just it keeps saying like, you need to have a unique name, but I use every possible thing.
The class took all of them. Maybe. Okay, so really quick, I want to go through this exercise. We have about 10 minutes left. What's up?
It's not accepting my storage account name, so I'm trying to figure out.
Oh, still have the storage account name.
Yeah.
It can be anything. You can just type a bunch of stuff.
I'm literally
Type a bunch of
typing in
letters.
Snacks names, and it's not taking it.
Somebody else just thought of it. Someone else was hungry when they were setting things up. Okay, so far in this class exercise, we've set up Gen Storage 2. That's what we're in the process doing. We connected to Data Explorer. So we downloaded Storage Explorer and signed in with our subscription. Let me pull that back up. It's not on this. Here we go. So we signed in with our subscription. You may or may not have to use the authentication account, the authenticator account. If you haven't had to set that up with your new account, you might not need to do that. I've had my account for long enough that they forced me. I think they do it after like 15 or 20 days. If anybody has a problem with the Microsoft authentication app, I can help you out with that. So the first step once you're there is to create a folder named crypto data in Blob storage. So in the Blob container, it says create Blob container. You can call it whatever you want. It's like your own file folder. That's the way you can think of it. I called it crypto data, and then I downloaded those CSV files to that Blob storage. You can upload them if you want. You can upload a folder of files, or you can just drag them on to there, which is what I usually do. If I were to drag another CSV file there. Should work. Oh yeah, it did. It's just doing it in the background. So it did drop it, and if it already exists, you can replace or not upload. So part of my problem is that I can't see the bottom.
Did you create blob container? Is that what?
Yep.
Okay.
So if you upload something, it'll start to say like in progress here in your activities. And then once it's complete, it'll say completed successfully. So this is a lot like if you used SQL Workbench and your succinct query ran successfully, it gives you like a little green check mark or a little X on it. The Storage Explorer is the same thing. So after you do that, those files are in Slack. You can download those and just drag those into that Blob container that you created. So that's why this Azure Storage Explorer is like super helpful with working with Data Lake, because it makes it easy to create folders or add a new table or drop files in or delete files or whatever you need to do. See files, download files. Maybe you created a new file and you just want to run it in Power BI or Tableau or something. Download it to your desktop and then just use it. All right, so after you're done uploading the CSV files, that's where we can, now that they live in the data lake, you can use Azure Data Explorer to explore them.
Jeremy,
Yep.
I'm not getting the data lake I created to show up in the Explorer.
It's not? Huh.
I
Yeah.
signed in with Azure. It says I'm connected and authenticated, and then I return to the data lake and nothing's there.
So you expanded storage accounts
Yes, I did.
and nothing for that?
I get attached containers, and it just says blob, file, queues, table.
And nothing underneath of it. Huh? Okay. Oh, that's how you can use the shared access key to connect to just a random node. Is if you connect to storage and you have somebody else's key, then you can do it under storage accounts.
I know when I open my block container, I like exit out of the, when it was authenticated on the localhost or whatnot. Like if you X out of that, you can't sign in, like you have to sign in again on the storage explorer. So like so like when it got authenticated in this,
So, yeah,
if I X out of it, it will, on the storage explorer, it's gonna ask me to sign in again, and this has to stay open.
oh, your browser has to stay open after you authenticated. So was that John? Was that
No,
you
I
that?
left it open. I saw that too.
Oh, you saw that too. So
Yeah.
John, that's you who's talking right now, right?
Yes.
Could you do me a favor here? Let's see.
I'm also having problems with the Synapse stuff and getting that to work too.
Okay. I might take another look, or we might, if you haven't been able to get that to work, I might, we might do that as an exercise together in Synapse Analytics. Let's see. We might run out of time today, though.
Okay.
John, do me a favor.
Would you be available
You-
tomorrow night by any chance?
Yeah, I could be available.
Okay, I'll send you a thing through Slack and we can connect up and then discuss what's going on if you want.
Okay, that sounds good. John, could you send me a screen? Could you hit this link to your storage accounts and send me what you see here? Should. Okay, so I'm putting this in Slack. You should see your storage.
I do see my storage on the Azure side, on the portal.
Okay, and you're connected with that same account?
Yes,
It's the same account that you're using?
yes.
Huh. Let's see. Under the same subscription, you set up ODSA subscription?
Yes.
Yeah, we might have to walk through it.
Okay.
So I can get my eyes and see what you're saying.
Okay.
That'd probably be the most helpful, especially with just a few minutes tonight.
All right. Thanks.
Yep, no problem. I'm gonna just walk through the rest of this the last few minutes here, also so everybody can take a look at this exercise. So we're almost all the way through the exercise if you're able to see all of their storage accounts here. And anybody else who can't see their storage accounts, let me know. Everybody here see their storage accounts through Storage Explorer? Anna's not able to either.
I can see mine.
Okay. I am going to, thanks for the confirmation on who can and can't. There are a couple people who can. So it's I did desktop support for a while when I was young, and one of the hardest things is like if you can't, like if you're like trying to like explain it to each other and you can't physically see it, it's like two people like throwing punches in the dark at each other a little bit. That's funny, and I'm trying to be a funny analogy, not literally. But let's see. I was going to walk through the rest of this. That's what I was doing. Okay. So one of the things is if you have that in the data lake, then you can use Data Explorer to be able to browse that data source that you have living there in the data lake. Okay, now we're back to it. Slideshow. Okay, so one thing we want to do once we're there is get data, create a destination table, configure the data source, and then select that data. So this is how we can do this in Data Explorer. stop my phone from ringing. It's telling me it's my bedtime.
I was gonna say, my head was starting to be reminded, set point for one, for Mondays and Wednesdays.
That's awesome. You go to bed at 8 o'clock.
No, it's just like when I start my routine.
No, no,
Blessing.
I do that with my kids too. It starts at 8 and then I fall asleep around 9:30. I try to. See the light. 10:30. Yeah. So inside Data Explorer, what you can do is you can get data and it'll bring up this menu. We now have it in Azure storage. It's kind of convenient to have a local file too and just to test out a local file and explore it. But we have ours in Azure Data Storage. You should have this Azure Data Storage that you set up. So this is like the repository, and then this is like the folder. So you can do a new table, create a new table to insert into. I already created the fact coin history. So I'm going to do this fact coin history too.
So we have to create.
Yes. All right, so configure the data source. So your subscription, Azure subscription ODSA, or whatever you have it named. The storage account would be whatever you named your storage account. In my case, I have an ODSA data lake. Then the container I created with it in it, that's where you right-clicked and you created the blob storage. It's called crypto data. You could do file filters if you want, but we aren't going to do that for this one. All right. So you have your files that are in here. Why it's showing funny for me is because it doesn't read Excel files. It needs CSV file. So all this data, it originally came from a web API that I used the JSON tool on that I showed last week. But what it does is that it flattened the JSON file to create this file that I have in the CSV files. So you can say first row is a column header. It's all along the top. Then you can see the data. It has the dates in this numeric format. It has the prices, market cap, volume, and so forth.
Ours looks different from ours.
You might have selected one of the other files in it. I think this one is coin history.
Are we gonna have to do that for each one?
No, you can just do it for one. It's
Or-
just exploring, just showing you how you can do this.
So you're fine with whichever we.
Yeah. So then if you get all the way through it, it starts to create a table for you. It does the mappings. It ingested the data sources. And then it asks you, what can you do with this data? You can explore the results using that KML language. And you can visualize data. So we got the data. You can explore the sample data with the query language. You can explore sample dashboards. You can actually hire people to help you, which is interesting if they put it in there. But you can create all these things. So let's go ahead and explore it. basic data. Oh, that install all of its own data, that's why. Okay. I didn't mean to do that. So let's go back home. So what you can do is create a new query. Let's go ahead. I'm gonna just get rid of that for a second. I didn't mean to do that. Okay. So you created this new data source, Data Explorer, and the fat coin history table. That's what you loaded your CSV table or CSV results and or file into from the data lake. And you got this table. So now what you can do is run the KMO query. So just basic syntax, just the name of the table. It's like a select star from that coin history. So this gives you everything in that table. There's also should be options here that you can add visuals to it if you'd like. Visual formatting. You can do bar charts and column charts and everything. Do line chart.
Once you create the table, you can't edit it, like name it. I think just done with
You
it.
can't. We'll do like here, we'll do cap by date so you can see the market cap of Bitcoin, or this would be all coins with the data source I used, and the line through its average. So I did this purely just from that query. I turned it into visual. And then what you can do here is pin it to a dashboard. So crypto total cap. So it's okay. Use existing data source if possible. So it's data source. You can either use an existing or create a new. Let's go ahead and create a new dashboard called crypto. Then view dashboard after creation. So now I've taken that data from the data source. I ran the KML query on it, created a graph. Now I can see that price over time. So Data Explorer is like a really quick way to be able to connect to data that's in the data lake, or you can do real-time data here. You can set up those sources and then be able to see trends and monitor different things in the data source. So really good for data quality purposes. You could set up dashboards to see like different values in the data sets and really be able to explore those quickly, see them and explore them quickly. So like if a new file comes, you refresh it in the data lake, say you get a refresh overnight, you can just refresh this dashboard, go in and see if you have the dashboard set up the way you want, see if there are any problems in the data set.
Also, you can edit the dashboard.
No, you can,
Yeah, so it could take,
dashboard, yeah, but you can't edit the table. Like you can't, once the table is established. Okay. But that, you're saying that, like, it updates the data, so the data,
It's updated.
yeah, automatically.
yep. So this one even says like as of 1 minute ago, early 4:30. Oh yeah, you know why it says this time? Because it's like England time. It's like Central meridian or whatever they call it. So yeah, it says even when it's updated or as of 2 minutes ago, and then you can refresh it on the data source and see the current trend. And then you could go back to the query. You could see the original query where you can just create a new query and continue to pin these things. And the syntax for that query, I included that in the notes for the class. So I kept everyone an extra 10 minutes. I owe you 10 minutes bad sometime, but thanks for sticking with me so we could get through that. I knew it was a lot to cover today, but we got through it. If anyone has problems setting anything up, and I could probably look at yours real quick. I'm going to schedule a time with John. Just go ahead and you can direct message me here if you're having any problems like with the homework or configuring resources like John was setting up, setting up Data Lake or Synapse Analytics or anything that you're having a hard time with. It's probably easier just for me to usually to get my, if it's a, go ahead and drop a screenshot in and see if it's something I could solve quickly. Otherwise, it'd probably be easier for me to just connect with you and we can solve it in 10 minutes, hopefully. That's the way it usually goes. I just get my eyes looking at the same thing the other person is, and it goes pretty fast. Unless it's a big time technical error.
You know why we create, we showed us how to do we added the fact coin history.
Yeah.
You know why when we create mine only showed one of three. I was trying to figure out what that was.
Oh, it only showed one of the 3 data sources. You only created one table, right?
Correct, but it only allowed me to do, like, the only one that showed up was the one I used. It was a dim.
Oh yeah, so there were 3 CSV files in that folder.
Right, which
Yeah.
you put it on the storage explorer.
Yeah, and you selected one to create. You only select one
It
CSV
only
file.
had one that allowed me to.
Oh, that's weird.
I guess that was the question. But that could be.
Let's see if I can do it real quick. So I go ahead. I'll create a new table. We'll call it dim coins.
Right this up.
So I'm intending this to be like an analytical data model. Sort of. Dim coins. Okay, dim coins. Storage account. Container is crypto data. Okay. Hit next. So it shows all of these for me. Dim coin is just like the mapping of the short code to like the long name, which is why it's a warehouse dimension. And then you can join this to your regular data if you wanted to. I'll just make sure this works. That's okay that last one is because that's an Excel file. So if I do a new query, yep, I refresh that and now the dim coins shows up. So I don't want to get data. So I probably want to do, instead of removing that other query, do a new query. Call this query dim coins. So really similar to SQL IDE or Explorer. That one worked okay for me. It only showed one in your storage bucket.
Well, the way you did it was different from how I did it, I guess. But you did it so fast.
Sorry. Yeah, I did a get data,
Right,
Azure storage,
correct, yeah. Then you go to the.
add connection. Oops,
Table.
no, I didn't. I don't need to add connection. I already have that connection.
Okay, let's have it.
So I did new table. Fact overview history is my other one.
So, you know, what was that?
Okay, I created that table. So under the subscription, in that storage account, in that new container I created, I hit next. This schema definition file, I pulled that down and it shows all of these for me. And when I did that, it said first column is header. Then does all the column names and data types, which is awesome. Then I finished, and then it creates all this for me. Right, did I go skip a step there? Hey, come take a look. And I know that you were having a problem with your storage account, weren't you? Are you still having a problem with
I
it?
finally got it downloaded, but I don't know what to do. I don't know.
Let me come help you out.
Yes.
Can I miss anyone on Slack real quick? I'll do that. I think we're good with. Okay.
We should go live, so I can like relaunch the last one.
Yeah, I did that right. Don't make me question
I know.
it. The second I did it. That I counted down and everything. And I didn't stop it.
So this is the one.
Okay. Go ahead and sign in your subscription. And then Azure. Okay. It says no subscriptions found. So in your Azure, are you using a different? Maybe using a different account. Let's see real quick. So using Outlook.com. Subscription. $50 okay, so that's your free loan. You created this. Looks like you created a storage account there. You have one in ODSA, I'm just curious. Yeah, it's in there. Okay, go back to storage. Okay, same with Azure. That's gonna be already, isn't it? Hit next. Already did that, didn't we? We're already logged in.
Do I have to like do it now?
No, should be okay. Extra, okay, extra resource. Or if you go to storage account and service. See ya.
Do I wanna do shared access every time?
Yeah, let's try to do it that way. You have to go back to, Azure. For some reason, it doesn't seem like your account's working the way we expect, so if you go there, yep. And somewhere in here, we should be able to generate, shared access. Actually, try one thing real quick. Try to open that in Explorer. Yeah, even that one says, cannot find a specified subscription. So I think that we do, let's try to do it the way that we were. Let's do this, or, let's go back. We get the shared access signature. We go to one other way you can do it is storage browser. You can do that this way instead of the block container. You can right click on block container, put those. You can do all of this from here, except it's kind of better to do it like that utility is kind of better. Instead of doing it through that storage explorer,
Do you think if I restart my computer, that might help?
you could try. It's weird though, it's versions of found. You could try it. I don't know if it'll help. I think that's helping you before. But if we find that shared access key, we should be able to do that way too.
Okay.
So, working?
No, so I put a new one, or I just did a,
Mhm.
then I did the container, I did everything,
Mm-hmm.
okay, next, right?
Mhm.
But you're saying there's something there that you had that allows you to drop down
Can I see your folder that you created?
for this one?
Yeah.
On
In
the
your-
storage?
Yeah.
Yeah.
Yeah, all of those are in there.
I thought maybe, like, I refreshed that, thinking that was what it was, but no.
If you go back,
Back is an X out of here, or go back to
just
storage?
hit, back is in the back button. So we're hit back one more time. So that puts you back, okay, as your data storage.
Mhm,
Okay, you created that new table,
mhm.
selected container.
And the way that, like, there's like no, like, no room to, like, it's really, it's just mine or yours, or that's it, it cuts off.
Can you expand that optional filters?
Yeah. Sure. Yeah. Oh, I already was.
Like having these filters on it? No. Okay, hit next.
And this is the one, the only one showing up, which is the dim scoring. Still image.
If you hit the yeah, I guess on the Mac it's yours is laid out differently.
So it does show that. I mean, it does show it. This is, I think.
Yeah, that's a different data source.
Yeah. So this is what I was looking for.
Yeah.
But, okay, so I have to go, okay. Because it's a Mac. Jeez, the one, is that why this is not working, or?
I guess so, yeah.
Oh, here it is. There you go.
But the spacing's weird.
Okay. Well, at least you figured it out.
Got
It
it.
says it's added, but it still has the same. The same problem with
Yeah, that one's like your local, that one's like your local, storage. Yeah, go ahead and remove it. Okay. Let's try to find that shared access signature again. Let's try to connect to it that way. I'll click on that one. Somewhere in here. Scroll down a little bit. Shared access signature underneath of it. Yeah. If you go down, generate key.
Have a good one. See ya. Bye. See you later.
See ya.
No, is it gonna have to change this?
That looks like the right time, huh? Go back up. Just sit down.
The only thing that I can think of is because it always wants me to log into my UNL account, if not, it's being weird.
Maybe. So that's code generating. That looks like it's like the year for account.
That's it, something wrong.
Is there anything we can fill out? I think that's optional IP address. Random ideas. I think it has something to do with your login account. Could open it in the browser now that we're logged out, or storage explorer now that we're logged out of your account. Try it. Can't do any of the above here though.
Click on this one, and then click on that.
I don't know. So, I did have one idea. What was it? I had it a second ago and I lost it. Sometimes I found that solving problems is just pure perseverance, trying different things. Printers are like the worst. I actually gave up on the printer at home and I hardly ever do that.
I was like, I got it to work technically, it's just they kept putting random packages out there every 6 months. I mean, it works that way.
I mean, if you go back to Azure, just log all the way out. Gotta sign out. And that's the only account you ever logged in with, right? Okay. I wonder if there's any problem with, Outlook accounts in Azure.
But that shouldn't matter either. As long as I can get in.
It all shows that if you have an Azure subscription. If we need to, maybe we can copy that subscription and move it into it. Now go to Storage Explorer. You click settings, yeah. Yeah. Go with that. Can't like sign in with a subscription either.
But this time it all makes good on it. Did I do it?
I think it's like something with this account or something.
Do you think I should uninstall and reinstall?
The software,
Yeah.
I think it has something to do with the Azure account.
This would be like a Microsoft account itself. I don't know if I want to do this or not, but yeah.
So it's weird that you have a login account. It's okay, you can see it all in the portal, but then when you do it in Storage Explorer, you log in with that same account, it doesn't like show me in the.
No, my only guess at this point is to uninstall and reinstall the Explorer. And just see if I happen to put something in.
I guess worst that happens is that you just do things this way. And you can create new containers this way instead of using Storage Explorer. Where's that over there? You like the storage browser here is close to the same. Instead of using that Storage Explorer. Are you using a Mac?
No, it's a Dell.
Oh yeah, it is Dell. That's kind of like an on Mac person. You can't do that.
No, I think it might be, I know, let's see, I haven't done that. I know that on my Google account, it has some weird security setting. And it would have issues when I would do some of the Python coding, especially if we had updates. I had to like somehow go around it. And I don't know how I did it, but my Outlook is not like that. I have not gone in there and done anything security-wise.
Outlook should work with Microsoft, it seems. So. You see what John what problem he's having.
Well, I need to be able to access or do some of this stuff for the homework then.
For your next homework?
For this homework, for the first one.
No. No. Data explores, Storage Explorer is more of a convenience. I always use it, and I've never had a problem with it.
Okay. I'm gonna.
But you can also like do all this stuff through your web browser like that too. It's just a little bit more painful, I feel.
Okay.
But you can still do it.
Yeah, because I'm gonna try to uninstall it, Explorer, and then reinstall maybe with some.
Could try it.
Yeah, and then see if that works, and if it doesn't, then I'll just put it around.
Sounds good. Thanks for working hard at it.
Hoping.
You're welcome. I will finish this up and ready to go home. Go to sleep. Past my bedtime. See ya.
Yes.
So this was class 3, cloud storage and databases with your instructor, Jeremy Bergman. Today we covered different kinds of cloud storages, the storage types, storage blob, queue, file share table, or relational and non-relational databases, different ways to store data for analytics and the different use cases. And this is Jeremy Bergman for Data Science Academy. Signing off for class 3, and class 4 will be on Wednesday, which covers data processing in cloud. See you then, and good night.